Hi, welcome back to the review for the Chem 4 final. In this video we're covering an example for finding pH of a weak acid. When you're calculating pH of something weak, to create the balanced equation at the top of the equilibrium chart, you're going to take the weak plus water, and then you're going to write out the products. And I'll show you how to do that in a minute. That's important. You're going to use a dice chart, an equilibrium chart that deals with dissociation. Dice charts, the only time you put moles into an equilibrium chart is if you have an acid plus a base, and we're not up to that yet. So, add water to the compound to create the balanced equation, then ice case solve, check sun. In these kind of problems, as always, you could be asked for the pH or pOH. You could be asked to calculate the equilibrium constant K, or you could be asked for any of the compound concentrations at equilibrium. So let's look at our example for this. Can you hit pause?
I don't know how to hit pause.
You don't know how to hit pause.
No, it was on the screen.
Fine.
Fine.
Okay. What is the pH of a 2.00 molar? Oh, there's acetic acid again. And there's its acetic hydrogen. What is the pH of a 2.00 molar acetic acid solution? And they're going to give us that K for the acetic acid is 1.08 times 10 to the minus 5. Notice it's very, very small because it's not letting go of its hydrogens. It's mostly going to stay acetic acid. First question, is acetic acid an acid, base, or a salt? Well, you remember this is our tricky acid because it's got the hydrogen at the end. So we know it's an acid. Second question, is it weak or strong? It's not in our strong acid song. Yes, and here it goes again. HNO3 and HBr, H2SO4. HCl, O2, O4 say high strong acids all. It's not in the song. If it's not in the strong acid song, it's a weak acid. So now we know two things. That this is a weak and that it's an acid. And so therefore we need an ice chart where we add water, and we need a K, which they gave us. So we're good to go. Let's see what happens. We need our balanced equation. So let's take our weak acid and let's add water to it. Since this is the acid, the water has to be a base in this problem. And you know, acids give away their hydrogens to bases. So what we're left with after acetic acid loses that proton is our conjugate base. Water gains a proton, so it's H3O+, but we know that that's really just going to be written as H+. So, water is a liquid. We know that liquids and solids have no place in an equilibrium chart, so I'm just going to cross it out. I-C-E. We need molarity in this chart because it's not a neutralization equation. What's our initial molarity? 2.00. What do we have at the start? Nothing. The reaction didn't start yet. We're freezing time. 0, 0. Remember, what you start with has to lose some of itself to create this. So we're going to subtract. We always use x. It's actually x times the coefficient, but since the coefficient here is 1, I'm just going to write x. Whatever is lost here is gained here, so I'm going to gain x times the coefficient, which in this case is 1. Coefficient 1, again, just plus x. So our concentrations of these two ions at equilibrium are listed as x, and our concentration here is 2.00 minus x. So let's write our K expression, because you need the chart and you need the k. We're going to write the products raised to their coefficients on top. X times x is x squared. There are no coefficients here that we had to put in. We're going to put that over our reactant, CH3COOH, and that equilibrium concentration is 2.00 minus x. Again, since this is a final exam and time is precious, hopefully they won't have you solve for that x using the quadratic formula. You can go ahead and just from the reactant, cross out that minus x, just to speed things up a little bit. Now, did they give us a value for k? Yes. So we're going to plug in for k. 1.8 times 10 to the minus 5. When it's just a number like this, you can assume that it's just divided by 1. And now we do crisscross applesauce. So 1.8 times 10 to the minus 5th times 2 is equal to x squared times 1, which is just x squared. You're going to multiply these two numbers, and we end up, did I write that number down? With x squared equals 3.6 times 10 to the minus 5. Well, we don't want x squared, we want x. This is how you solve anything with an exponent, an unknown raised to an exponent. You take the number, you put 1 over whatever the exponent is, and that will give you x. So let's solve that. Hopefully we don't need what I just erased. So, for x squared equals 3.60 times 10 to the minus 5th, x is going to equal our number raised to 1 over our exponent, which is 2. You're going to put this number in your calculator with the parentheses. In between here, you're going to hit enter. You're going to hit that little arrow up, and then you're going to put in 1 divided by 2. When you do that, x is going to turn out to be 0.006. Well, I shouldn't have erased that board, but I'll show you what that represents. In our equilibrium chart, ICE. These both were x. See what we just solved for? And this was 2.00. We just solved for H plus. We need that for pH. So we're going to say our H plus concentration, which is equal to x, is equal to 0.006 molar. Now we're done pretty much. We just have to plug that into the pH formula. Remember, pH is always that little minus sign with the brackets around it at the bottom of the calculator, minus log of the H concentration. So we're going to have minus log 0.006. And when we do that, we get 2.22184,875. We're at the end of every problem we do in chemistry. We SUN. The S stands for significant figures, the U stands for units, the N stands for the number in the answer. Number of significant figures go back to the problem. We have 3 significant figures here. Our number has a decimal, so we start on the 0 all the way at the end, even though it's not a number. 1, 2, 3. Look at the other number. 1, 2. So technically, our answer should have 2 significant figures. Now remember, only the numbers after the decimal figure, after the decimal are significant in pH, for pH. So I'm going to underline the two numbers after the decimal. So our pH value reduces to 2.22. I didn't need to round up this 2 because the number after it was not 5 or greater. So our answer is pH equals 2.22. Does that make sense? Yeah, it's acidic. Ice, case, solve, check, sun. Units. Does pH have units? No. K doesn't have units. Shouldn't have done that to the K. And pH, POH, they don't have units either. That concludes our example for pH of a weak acid. We forgot to
I think we forgot to
I
set
hope
the
so.
clock. Right? All set?
Yes.